Section 8-7 is all about the discriminant and complex numbers. So first off, let's discuss what the discriminant is before we get into complex numbers. Now, the discriminant is part of that quadratic formula that we learned about in our last unit. So the discriminant is just this value, b squared minus 4ac. So when you have a quadratic formula or a quadratic equation in the form ax squared plus bx plus c equals 0, you just plug in those values. B gets squared, and you subtract 4 times a times c, and that would be the discriminant. That's what it's called. Now this is the expression under the radical sign in the quadratic formula. So I wrote it in red here. X equals negative b plus or minus the square root of b squared minus 4ac, all of that divided by 2a. This is your quadratic formula. This part in red, b squared minus 4ac, is what's called the discriminant. And this will determine the number and types of solutions. And I'll show you what I mean by that. On your next slide, or your next piece, we have the concept summary about the discriminant. Now, here are 3 different equations given. These are all quadratic equations because they have the x squared in them. That's our biggest power of x. And if we were to graph this one, x squared minus 6x plus 8, parabola would look something like this. Notice that it touches the x-axis right here and here. There are 2 x-intercepts, or there are 2 solutions to this one. This one, x squared equals 0. That's kind of our normal parabola that everything else kind of draws from. That has 1 x-intercept right here at 0. This one, x squared plus 2x plus 2 equals 0, has no x-intercepts. It does not touch this line at all. So, since this one touches twice, we'd say there are 2 real solutions. And by real, we mean that they are not imaginary. This has 1 real solution. Again, we mean that they are not imaginary. This one, because it doesn't touch this line at all, we might think that there are no solutions, and that's correct. There are no real solutions. There are 2 imaginary solutions. And we'll go over what imaginary means. Now the discriminant, that b squared minus 4ac, if we were to take these numbers, so a is 1, b is negative 6, c is 8, we plug those into b squared minus 4ac, comes out to 4, so it is positive. Anytime the discriminant is positive, there are 2 real solutions. This happens anytime we have a quadratic function. If you can find the discriminant and it is positive, there will be 2 real solutions somewhere on the x-axis. Anytime your discriminant is 0, so we plug in b squared minus 4ac, subtract everything, and we end up with 0, like this. That means there's going to be 1 real solution. It's only going to touch this line at 1 spot. And anytime that we get a negative discriminant, b squared minus 4ac equals a negative number. In this case, it came out to negative 4. That means there's going to be 2 imaginary solutions. It will not touch this line. It's either going to be above it or somewhere below it. So let's go over imaginary numbers then, or complex numbers. I is what's known as the imaginary unit. Whenever we have an imaginary number, we will use this letter I. I is kind of like a variable, except for it means an exact number. I is the square root of negative 1. Now normally we think, well, there's no such thing as the square root of a negative, because nothing times itself could equal a negative number. But this number I is what we call the imaginary unit, and it is such that I squared equals negative 1, or I equals the square root of negative 1. So how does that help us? How does that look? Well, if we need to simplify things like the square root of negative 81. Okay, at first that might sound like, well, we can't do that. That doesn't make sense. There's nothing times itself that'll equal negative 81. But if we split that up into the square root of 81 times the square root of negative 1, so we can split apart these square roots like that. So we have the square root of 81 times the square root of negative 1. Square root of 81 is 9. Square root of negative 1 is I. So we will call this 9i. Now in previous units, we said that this would be plus or minus So you'd think this might be plus or minus 9a. Do not do that for these ones. Because this is our negative part right here, this takes care of the positive or negative. So these will only be positive for this one. So this would be called positive 9i. Let's look at the second example. If we have the square root of negative 56, so we can split that up into the square root of 56 times the square root of negative 1. We don't know what the square root of 56 is, so we'll leave it like that. Square root of negative 1 is I, so we would call this square root of 56 times I. Notice that I is not underneath the square root sign. And lastly, if we have 30 times I squared, 30I squared. Notice it looks a lot like if we were to say 30x squared. We write it right next to each other. X is a variable. I technically is not a variable. We already know exactly what I equals. It's the square root of negative 1. So it's not quite the same as a variable, but you can kind of treat it like a variable. Well, 30 times I squared means 30 times negative 1, because I squared equals negative 1. So 30 times negative 1 equals negative 30. So if you have some number times I squared, it means negative that number, because I squared is negative 1. Oops, wrong way. So, example 2, we're going to find the value of the discriminant and describe the number and types of solutions for this equation. So, remember, every single time we were looking at quadratic functions, we want them in standard form. Ax squared plus bx plus c equals 0. This one is already in standard form. What we're looking for is the discriminant, b squared minus 4 times a times c. So we have to ask ourselves, what is a? That's this first coefficient. It's not 4x squared, it's just 4, just the number that's out front. What is b? Again, it's the coefficient, the one that is in front of x. Technically, because this is minus, not plus, we would say that it is a negative 28. And the last one, c value, is our constant in the end. It is 49. A is 4, B is negative 28, C is 49. Plugging that into this formula, b squared minus 4ac, well, b is negative 28, so it's negative 28 squared, minus 4 times a times c, means that it's minus 4 times 4 times 49. Simplifying all of that, negative 28, take that squared, would be 784. 4 times 4 times 49 is 784. So 784 minus 784 equals 0. This is the value of the discriminant, 0. Now, looking back at our table, when the discriminant is 0, this one right here, there is one real solution. It'll look something like this. The parabola will either kind of go up or go down, but that vertex will touch right on the x-axis. So there's only one solution. So, because it is 0, we would say there is one real solution. And that's how we use the discriminant to find the number and types of solutions. Let's look at another example then. Find the value of the discriminant and describe the number and types of solutions. Again, we always need to put things into standard form. This one is not in standard form. We have x squared plus 1 equals x. We need to get a 0 on this side. So on both sides of the equation, we will subtract x. When we do that, this will go away and just leave 0. And we'll have a minus x in here. So our equation will now look something like this. X squared minus x plus 1. If it helps you, write in that there's a 1 in front of this and a 1 in front of this. 1x squared minus 1x plus 1 equals 0. Now we ask ourselves, what is a, b, and c? A is the value out front of this one, so it's not 1x squared, it's just 1. B is the coefficient in front of this one, so it's not negative 1x, it's just the negative 1. And c is this last constant, that's all on its own. It is the positive 1. Plugging these values, a is 1, b is negative 1, and c is positive 1, into this formula, b squared minus 4ac, we would get negative 1 squared minus 4 times 1 times 1. Negative 1 squared is 1. 4 times 1 times 1 is 4. So we get that our discriminant is negative 3. Now again, I'm going to go back here. If we look back at our table, when the discriminant is negative, there are two imaginary solutions. It looks something like this. Our parabola will never touch this x-axis. So we would say, if this is negative, there are two imaginary solutions. Example 3, A and B. State whether the discriminant is positive, negative, or 0. Just by looking at the graph, we should be able to tell what negative or b squared minus 4ac is. We don't have to plug these in to find that out. We can just look at the graph and check it. Because this graph does not touch this at all, we know that it is negative. If you wanted to double check, A is 2, B is 16, C is 34. Plug everything in. 16 squared minus 4 times 2 times 34 becomes 256 minus 272 equals negative 16. So it is in fact negative, like we said. Part B, we've got y equals negative x squared plus 4x minus 1. Remember, think of this as a negative 1 for our A, positive 4 for B, and negative 1 for C. Just by looking at our parabola, we can see that it touches 2 times. So there are two real solutions, meaning that our b squared minus 4ac has to be positive. The only way that it would be 0, I'm going to draw this in green, is if it looked something like this. Came down, touched at one point, and went away. If it only touches at one point, that's how you know your discriminant is 0. Double checking, b squared minus 4ac, 4 squared minus 4 times negative 1 times negative 1 means 16 minus 4, which equals 12. Again, that is a positive value. So that all checks out. You don't need to double check it like this. You should be able just to look at the graph and see how many times it touches the x-axis to say if it's negative, positive, or 0. And our last example, example number 4. Solve this using the quadratic formula. Every single time you solve with the quadratic formula, make sure you get it into standard form first. X squared plus 13 equals negative 6x is not in standard form. We first need to get it set equal to 0, so we will have to add 6x to both sides. Add 6x and add 6x. When we do that, it'll now look like x squared plus 6x plus 13 equals 0. Now we are in standard form. I don't think I wrote this off on the side, so we're going to do it now. A in this case equals 1. There's a 1 in front of this. B in this case equals 6, positive 6 right there. And C in this case equals 13. A is 1, B is 6, C is 13. We use all of those numbers and plug it into that quadratic formula. X equals negative b plus or minus the square root of all of this. B squared minus 4 times a times c, all of that divided by 2a. So here are all of our numbers plugged in. We're going to simplify it out. Negative value of 6 is just negative 6. Plus or minus the square root of, well, 6 squared is 36. 4 times 1 times 13 is 52. All divided by 2 times 1 equals 2. So this was our first step of simplifying. Next step, 36 minus 52 is negative 16. So it's negative 6 plus or minus the square root of negative 16. Now normally before we would say negative 16 doesn't work. We can't have square root of a negative. But we know now that we can split that up into square root of 16 and square root of negative 1. So we would call this 4 times I. So we have 6, or negative 6, plus or minus 4 times I, all over 2. Now at this point, we can divide the 2 from each of these pieces separately because there's a plus or minus in between them. We can't combine a real number, 6, with an imaginary number, 4i, but we can divide the two from them. Because remember, treat this as though it was a variable. Negative 6 plus 4x, negative 6 minus 4x. We can't combine unlike terms, but we can divide from both of them. Dividing the 2 from both of them leaves negative 3 plus or minus 2i. You can leave this as your final answer, or if you want to be a little more exact, you can split it up. Negative 3 plus 2i or negative 3 minus 2i. Either set of answers is acceptable, but this would be your end answer, solving the quadratic formula with a negative discriminant, or a complex, should I say, imaginary number. Anything that has an imaginary number in it, a value of I, is called a complex number. And this will end it for 8.7.